All right, looking at chapter 7, lesson 2, specifically examples 3 and 4. Example 3 is going to go over compound interest. There's a formula for this. You will be given the formula. However, you need to know what all of the variables within this stand for. That will not be given to you. So, A is the amount that's going to be in the account after so many years. That's generally going to be your answer. P is the principal amount that's invested. So a word problem with this will look something like somebody put $1,000 into an account. The interest rate of the account is 5%. It's compounded monthly, and they let it sit in the account for 18 years. So you're really just plugging in numbers into this. So the R is the rate. The rate is going to be given to you as a percent. However, whenever we're plugging into a formula, remember that you cannot multiply by a percent. So you need to change your percent to a decimal. So if I had something like 5%, 5% it is a decimal would be 0.05. Then N is the number of times it's compounded. So if it's annually, it's going to be 1. If it's monthly, it's going to be 12. If it's semi-annually, it would be 2. Those types of things. And then T is the number of years it's sitting in the account. Okay. So looking at an example with this, it says an investment account pays 5.4% annual interest that is compounded quarterly. If $4,000 is placed in this account, find the balance after 8 years. So plugging into my formula, I'm trying to find the amount after 8 years. So A is what I'm looking for. P is my principal amount, so how much I originally placed in the account. So I originally placed $4,000 in the account. Then in parentheses, I would have 1 plus. R is your rate. So it is 5.4%. However, your percent, you need to change to a decimal. So 5.4% as a decimal is going to end up being 0.054. Then it tells you the number of times it is compounded. So you will notice there's an N here and an N here. Both of those are the same number. So if something is compounded quarterly, if you think of quarters, that would be 4. So I'm going to plug in 4 for both of the N's. Then T is the number of years it would be sitting in the account, kind of accruing money. So it tells you to find the balance after 8 years. So 8 would be my T value. So from here, I am then taking all of this and plugging it in to my calculator. You can plug the entire thing in at one time, especially if you have a like the TI-84. If you're using one of the other calculators, you may have to do it in pieces, as far as like actually multiplying your 4 and your 8 and your exponent and kind of breaking it a piece. However, whenever you solve this, you would get that it is 6,143.56. So that is how much money would be in the account after 8 years if you started with $4,000. So basically you put $4,000 in an account, you just let it sit there, accrue money for 8 years, and that is what it would end with after 8 years. So that is what your answer would be to that question. Then example 4 is your last example in the set of notes. So example 4 is similar to example 1 and 2 from earlier in the section. So we did solving exponential equations. These are solving exponential inequalities. It's the same concept as far as having to have the same base number, except for now you're going to end up with an inequality versus an equal sign. So for this question, I have a base of 5 here. That's my lowest base that I could have. So I need to change my 625 to have a base of 5. The other issue with this is one is a whole number and one is a fraction. We'll kind of talk about how you change that in a second, but I'm going to worry about 5 to what power is going to give me 625, so I can at least make it the same base first. So 5 to the 4th power is what is equal to 625. So if I rewrote that, I would have 1 over 5 to the 4th. I don't want a whole number and a fraction. So if I have something that's in the denominator like this, I can move it to the numerator. Whenever I do that, I'm going to end up with a negative exponent. So that's why it became a fraction in the first place. Is I don't want a negative exponent. However, in this case, I do want a negative exponent because I'm trying to get the same base number. So my new problem that I'm working with is 5 to the power of 3 minus 2x is greater than 5 to the negative 4th power. So similar to the other questions we did with this, now that I have the same base, I'm not really worried about my bases. My bases are going to cancel out. So I'm just going to end up with the problem that is within the exponents. So I would end up with 3 minus 2x is greater than negative 4. Then I'm just solving like I would for a normal equation. So I'm going to subtract the 3 from both sides. So now I have negative 2x is greater than negative 7. I'm going to divide by negative 2. Remember, when you divide by a negative with inequalities, your inequality symbol sign flips. So instead of greater than, it's now going to be less than. And then I have a negative 7 divided by a negative 2. So I will end up with x is less than 7 over 2. You can leave that as a fraction, change it to a decimal. Either answer option is fine. Okay, so that is it for 7-2 notes as far as solving exponential equations and inequalities, and then that one problem with compound interest. So